Hello, Algebra. Today we are moving on to the Day 6 notes for Unit 10. So you should have those out. In our last video, we talked about factoring. All right, and when we factor, we're going to use a box problem. We'll do maybe an example or two up here, but then we're going to get to the new stuff. So last time we did something like number 2. Remember, you want it to be in descending order, x squared, then x, then the number. And then from there, it's got to multiply to be the last number, 15 in this case, and add to be the middle number, in this case, 8. So you got to think about all the numbers that multiply to be 15, and the numbers that multiply to be 15 that would add to 8 are 3 and 5. Once you have those numbers, you create your two sets of parentheses, x going first in both of them. Positive 3 means a plus 3. Positive 5 means a plus 5. And again, it doesn't matter which one has the plus 5, whether it's the first parenthesis or the second parenthesis, it doesn't matter. And then if you want to check, you can multiply these out, x times x times 5, x times 3, 3 times 5, and combine like terms, you should end up with the original back. So you can always double check by multiplying. All right, but now what we're going to do is we're going to be going on to problems that have, eventually what we're dealing with is problems that are factored and set equal to 0. All right, and then we're going to be solving these. So in our last video, we didn't actually solve, we just factored. And what we're going to be doing today is we're going to be solving some of these. All right, if you remember a long time ago, when we did like quadratic equations, we found the x-intercepts. All right, what we're going to do is we're going to use this equation here and we're going to graph it. I'm not going to show you on the calculator how to do that, but if you were to graph this thing, it would look something like this. It would make a parabola. We did a lot of parabolas in our last unit before we got right in Unit 9. So if you were to graph this thing would cross the x-axis in two spots. It actually crosses the x-axis here at 5, 0 and here at negative 2, 0. All right. If you look at the relationship between the zeros, the x-intercepts, and this equation, all right, so if you were to find these, your values are negative 2 and 5, all right. The relationship between these is, if you notice, if you were to set x plus 2 equal to 0 and you solved it, you're going to subtract 2 from both sides, you would end up with x equals negative 2. And if you set x minus 5 equal to 0 and solve for x, so you add 5, you're going to get x equals 5. So when you set each of those pieces equal to 0, you're going to get the x-intercepts, or the solutions. All right, and so that's what we're going to be doing with these problems, is we're going to be using something called the zero product property. Okay, so once something is factored, which you'll notice all of these problems on this page are factored for you. We'll do some where that won't be factored soon, but for now all of these problems are factored. Once a problem is factored, you can use something called the zero product property, which is actually something you already knew. You just didn't maybe know it was called this. Zero product property basically says that anything times 0 is 0. All right. So we're going to abbreviate zero product property to be ZPP. You'll see that used quite a bit. ZPP is zero product property. Anything times 0 is 0. All right. When we do the ZPP, we're going to, number 1, make sure it's factored. All right. Make sure it's factored. So we want it to look like the problems that we were doing in the last video. We want it to look something like number 1 here, where we have a parenthesis of something times a parenthesis of something else. Once it is factored, what you're going to do is you're going to set each piece equal to 0 and solve. All right, that's the goal. Set each piece equal to 0 and solve. Kind of like I did on this problem over here. We set x minus 5 equal to 0 and solved. That gave us one of the solutions. And then we set x plus 2 equal to 0 and solved, and that gave us our other solution. All right, because if this parenthesis were to equal 0, 0 times anything is 0. So we're going to set each piece equal to 0 and find out what those pieces are. All right, so we're going to solve each of the following using zero product property, ZPP. The answers that we get will represent the x-intercepts, all right, where this thing crosses the x-axis of our parabola. So for this one, it's already going to be factored. So step 1 is done. It's factored. Step 2, we set each piece equal to 0 and we solve. So we're going to set x minus 3 equal to 0 and we're going to set x plus 4 equal to 0. All right. When you do that, you're going to add 3 to both sides. You get x equals 3. And for this one, you subtract 4 from both sides. You're going to get x equals negative 4. All right, so you've got two solutions. It's two x-intercepts. If you were to graph this, you won't have to do this, but if you were to graph this, this parabola would end up crossing the x-axis here at 3, or 3, 0, and it would cross the x-axis here at negative 4, or negative 4, 0. All right, so those would be your x-intercepts. All right, let's look at number 2. Same idea. It's already factored. Step 2, set each piece equal to 0. So we're going to set 4x plus 3 equal to 0 and x plus 4 equal to 0. This one you're going to have a couple steps. You're going to have to subtract 3. Remember, you do any addition or subtraction first, then divide by 4. And you get x equals negative 3/4. The other one is just one step. You get x equals negative 4. So those would be the two x-intercepts for that particular graph. All right, number 3, you'll notice it's a little bit weird. We have x minus 10 times 2x plus 4, but then we also have an x out here. Anything that's being multiplied together has to be set equal to 0. So we're going to set x equal to 0. We're going to set this x minus 10 equal to 0. And we're going to set this 2x plus 4 equal to 0. And then we're going to solve all of them. This one, it's already done. X equals 0. This one, add 10 to both sides. You're going to get x equals 10. And this one, you're going to minus 4. You get 2x equals negative 4. Divide by 2. You get x equals negative 2. All right. Number 4 is a little bit different because it does have 3 things, just like this one did. But we can't set 3 equal to 0. That doesn't make sense. 3 can't be equal to 0. So for that piece, you can't do anything with. You're only going to be doing 4x plus 10 equal to 0. And x minus 26 equal to 0. So you're only going to set the pieces that actually have an x in them equal to 0. 3 doesn't have an x, it's just 3. 3 can't be equal to 0. All right, and then you're going to minus 10 from both sides. You get 4x equals negative 10. Divide by 4, you'll get a fraction. You can reduce it on your calculator. You get negative 5/2. This one, just add 26 to both sides. You get x equals 26. Okay. The other one, let's see, we'll look at number 5 real quick. With number 5, you've got 4x. You can set that equal to 0 because it does have an x. You can set 2x plus 3 equal to 0. And you can set x minus 5 equal to 0. This one you can divide by 4. You're going to get x equals 0. This one you can subtract 3. You get 2x equals negative 3. And then divide by 2, you get x equals negative 3/2, or negative 1.5. And this one you add 5 to both sides, you get x equals 5. All right. Number 6 is a little bit weird because it's got the squared there, but you're still going to treat it the same way. You can't set negative 2 equal to 0, so there's nothing we can do with that. The only thing we're going to do is just set x plus 11 equal to 0. Subtract the 11 and you get x equals negative 11. All right, so that one only has one solution. It only crosses the x-axis in one spot. And so now what we're going to do is we're going to put these two ideas together. Okay, I'm going to skip over this. What's going to happen is you'll notice that these problems on the next page say factor and then solve. Solve means that you're going to be setting things equal to 0 and solving. All right. Set things equal to 0 and solve. All right. These are going to be different than the ones we started with. You'll notice these problems have an equal sign and they have equal signs in them. All right. The ones that we started off at the very beginning of our notes, the ones like yesterday, did not have equal signs. The ones that don't have equal signs just have to be factored. These ones have to be factored and solved. When you do these problems, first thing you want to do is you want to make it equal to 0. If it's not already equal to 0, move things around. Second thing, you're going to factor with your box problem. Okay? And then the final step is you're going to do the ZPP. All right? You're going to set it equal to 0 and solve. Those are the steps for these problems. So in number 1, we want to make it equal to 0. Done. We want to factor, so we need to make sure it's in descending order, which it is. We do our box problem like yesterday. It's got to multiply to be the last number, 50, and add to be 15. So think about all the numbers that multiply to be 50, and the numbers that are going to work that add up to actual 15 is 5 and 10. So 5 times 10. So you're going to have two sets of parentheses. It's x plus 5 because it's positive 5, and x plus 10 because it's positive 10, and it's still equal to 0. Then we do what we just did on the previous problems. We're going to set those equal to 0 and solve. So we're going to set x plus 5 equal to 0 and x plus 10 equal to 0. You're going to minus 5 on both sides, minus 10 on both sides. You're going to get x equals negative 5 and x equals negative 10. Those are your solutions. If you were to graph it, it would cross the x-axis in those locations. Okay, let's try number 2. So in number 2, same idea, make it equal to 0, check. Factor it, so box problem, it's got to multiply to be 6 and add to be negative 5. Since it's got to add to be a negative, we need some negative numbers. So instead of like 6 and 1 or 3 and 2, we're going to do negative 6, negative 1, negative 3, negative 2. And negative 3 and negative 2 is what's going to make it add to negative 5. So we've got two sets of parentheses. It'll be x at the beginning of both, negative 3, so minus 3, negative 2, so minus 2. And then you set those equal to 0. That's our last step. So x minus 3 gets set equal to 0, and x minus 2 gets set equal to 0. And you're going to get x equals 3, and this one you're going to get x equals 2. So two solutions. All right. Number 3 is a little bit different because it's not equal to 0. If it's not equal to 0, you have to move it. So it's going to be, we're going to add a 7 to both sides. When you add the 7 to the left side, it cannot be combined with anything else because one of them has an x and one of them has an x squared. So the plus 7 just kind of gets tacked on at the end. Then we can factor this thing. So it's got to multiply to be the last number and add to be the middle number. All right, so it's got to add to be a negative, so I don't want to just use 7 and 1. I'm going to do negative 7 and negative 1. Those will add up to be negative 8. So I'm going to make my two sets of parentheses, and I'm going to put the x at the beginning of both, and I'm going to put a minus 7 here and a minus 1 here. And now we set it equal to 0. So we're going to set x minus 7 equal to 0 and x minus 1 equal to 0. Add 7 to both sides, add 1 to both sides. You're going to get x equals 7 and x equals 1. So those are going to be your solutions. Okay. Let's see. For number 4, we've got x squared minus 36 equals 0. It's equal to 0. We need it in descending order, and there's no x, so I'm going to put a 0x, just like we did in some of the problems yesterday. And it's going to have a box problem. It's got to multiply to be negative 36 and add to be 0. Those two numbers are going to be 6 and negative 6. So we factor it, and we're going to have x plus 6 and x minus 6. And then we set those pieces equal to 0. So we're going to set x plus 6 equal to 0 and x minus 6 equal to 0. All right, and you're going to set those equal. You get x equals negative 6 and x equals positive 6. So x equals negative 6 and x equals positive 6. So those are going to be your solutions. Okay. Alright, so we're going to continue this into the next video because there's not quite enough time. So go ahead and start the next video. We'll finish up these next few problems.